All right, let's talk just a little bit about limits. Limits are kind of neat, and they have a little bit of they can have a few sort of tricky properties. So you check out the course textbook, and you can go over sort of the formal definition of the limit, or what limits are. Let me just kind of draw us a real quick example here. So let's say we have some function that sort of comes up like that, and then right there it jumps up to there for some reason, and then it kind of comes back down, comes back up to there, and then it's undefined right there, and then it sort of squiggles on and does its thing. Let's say this is call this one, call this one, call this 3. Let's call this 3, and we'll call this 2. All right, so that kind of give us a little bit of something to work with. If there's no breaks in the line, the limits are fairly easy. But when there's these little bit of breaks, or if it's undefined at a certain spot, it can get a little complicated. So let's take a look at this in particular. So we'll call this is our f of x. So let's look at this first point. So what's the limit as x approaches 1? So that's this point. What is that limit of f of x going to be? Now, you'll notice here that this jumps. So you might be tempted to say, oh, well, obviously it's 3 because it's defined here. Like if you plugged in, 1 to your f of x, you'd get it equals 3. But in this case, that's not necessarily, or that isn't going to be the answer. In this one, it's going to be 1. Because remember, it's as x approaches 1. At the exact point, x equals 1, it equals 3, and that's true. But as it approaches from each side here, it's going to approach 1. So this can be kind of one of those funny instances where the limit of this is not necessarily going to be how it's defined on it. And so let's take a look at this case. So let's say now we're moving on to 3 and this point right there. So let's say we want the limit as x approaches 3 of f of x. All right, so what would this be? Well, here's 3, and so as we approach it in here, and as we approach it here, we see that, well, that's sort of not a straight line, but, kind of use your imagination. We see that that's going to approach it at 2. So what this illustrates is a limit can exist even if there's no solution. So a limit can exist if there is no solution, right? Which is kind of what that shows. Or in this case, the limit can be, even if there is a solution, the limit can be different than what the actual solution is, which is kind of what this shows. So let's look at a second point here that's really important that you have to keep in mind, and it goes over a little bit in the book, but the function needs to approach the same number for it to have a limit. So the function needs to approach the same number. So the way that that's described is the limit as x approaches some value a exists IFF. That's mathematicians, we're kind of inherently lazy and we like our abbreviations. So IFF is if and only if. So if and only if the limit as x approaches a from the left equals L, and the limit as x approaches a from the right equals L. So see, they both have to approach this same value. If they don't approach the same value, then there is going to be no limit for at least that particular section that you're looking at. So let's draw ourselves another graph here. Hopefully, yeah, that's showing up on the screen. Okay, so let's say we have some function that kind of comes up like this, and hits the spot, then jumps up here, and goes whoop, out like that. So we'll give this, let's say this is 1, and that's 2. Say that's 1. Okay, so maybe you're on a test or something, and the question is, what is the limit as x approaches 1 of f of x? Well, you'll see now there is a limit. So the limit as x approaches 1 from the left, so that's that little minus sign. Well, that's going to equal 1 because it approaches 1 and gets close. And then in this case, the limit as x approaches 1 from the right, put it out there. Well, that equals, coming this way, that equals 2. Well, 1 is not equal to 2. There you go. So since that doesn't approach the same value, then at 1, no limit is going to exist there. So that's kind of some of the trickier parts of limits. That they're fairly straightforward, and they're really nifty and can be handy to use. So go ahead and that should give you a good foundation for some of the trickier things, and the rest of it should be fairly straightforward.